Hi, grade 9. We are taking now a new lesson called algebraic expression, equation, and monomial. We need to understand a little bit the difference between the three. Algebraic expression is a mix between constant, like 4, and let's say a variable, like a, and hidden multiplication. This is algebraic expression. For a, it's a mix between, again, constant, variable, and multiplication. What about division? 4 over a. Again, this division, it's acceptable too. So it's mixed between constant, variable, and division. What about only 4? Actually, 4, it's algebraic expression since we can imagine that it's multiplied by hidden a exponent 0. And from previous, we got that a exponent 0 equal to 1. That's why this equal to 4. So 4, it's acceptable as algebraic expression. What about a only? Can we accept it as algebraic expression? Yes, because the constant is hidden. There is a hidden 1 because 1a is the same as a. So these are some form about algebraic expression. But what the meaning of equation? Equation is a mix between algebraic expression and the equal sign. So if I'm saying, let's say 4a plus 2 equal 10. Because of this equal sign, we call it equation. So from the left side, there is a mix between variable and constant and another constant and operation as a plus. And in the right side, there is another algebraic expression, but between them there is an equal sign, and this equal sign make this line as equation. So this is a difference between algebraic expression, that it doesn't have the equal sign, but the equation has an equal sign. Only make sure that you understand this equal sign that I added here to show you that these are the same. But the algebraic expression doesn't have equal sign, only the equation. What about the monomial? Monomial, it's algebraic expression like 4x cubed. This is monomial. There is no operation like addition or subtraction, because this one, we call it as a term. So if I have 4x cubed plus 2x squared minus 2x plus 1, we cannot call this as monomial. Monomial is one term only. So you can see here that the addition, the subtraction, and the addition can separate between these terms. So this is the first term, this is the second term, this is the third term, this is the fourth term. So one term only, we call it monomial. But if I'm adding other terms, we don't call that monomial. Only one term is monomial. If I'm adding 2, it's going to be binomial. If I'm adding another, trinomial. If I'm adding other, polynomial. So I'm going to explain that in other lessons. But for the moment, if I choose only one term, we call it monomial. So you can see that the algebraic expression and monomial, they are very close to each other, but the equation is something else. The equation has to have the equal sign. Now let's take a little bit some example as a review of what we got from the exponent law, and we can practice, and we will see if at the end we will get monomial, yes or no. So we'll see. So I have p squared times q to the power 7 times r to the power of 9 between bracket, and after that another bracket, p exponent 8, r exponent 3, divide by p exponent 3 q r exponent 4, the whole thing squared. So before we do that, we need to make it a little bit simple for us to simplify at the end. So I'm going to repeat the p squared, the q7, the r to the power of 9 times p to the power of 8, r to the power of 3. I remove the bracket. Here I need to work a little bit since there is power of 2. You know power of power, that means we multiply. So the p exponent 3, it becomes 6 because 3 times 2 equals 6. The q, instead of 1, it's going to be 2 because 2 times 1 equals 2. And the r exponent 4, it's going to become as exponent 8 since 4 times 2 equals 8. Now I can simplify. How? I will take, let's say, the p first. So I can say like that, p to the power of 2 plus 8. Since I'm multiplying p and p, we are multiplying, so we add the exponent. What about the p as division? We subtract it. So that means minus 6. I finished with the p. Let's go for the q. The q, I have 7, and I don't have anything else. So 7, okay. And after that, I have q as 2, but as a division. That means negative 2 or subtracting 2. After that, I have r. R, I have 9 and 3. They are multiplying together. That means 9 plus 3. After that, I divide by r to the power of 8. That means minus 8. Now, I can simplify more and more. 2 and 8, 10. 10 minus 6 equals 4. Q to the power of 5. R, I have 9 minus 8 equals 1. 1 plus 3 equals 4. Now I ask myself, the result is what? Right away, I can say monomial. Why it's monomial? Because they are separated by a multiplication, but there is no addition, there is no subtraction. So again, if you have something like that, you can write it as P4, Q5, R4. Hidden multiplication, so we write it as one term, one term. If I'm adding or subtracting, it's going to be another term. In this case, we cannot call it monomial. We call it binomial, and so on. So this is monomial really, and this is the answer of the first one, because we have a question to simplify. Now, what about the second one? I have a squared, b to the power of 5, times a to the power of 8, times b to the power of 3. I remove the bracket because it's multiplication. Now, when I multiply the same base, you remember, I add the exponent. So it's going to be a 2 plus 8. B, again, the same base. That means 5 plus 3. That means at the end, a to the power of 10, b to the power of 8. Again, I ask myself, is this a monomial? Yes, it's monomial. Why? Again, because there is no addition, there is no subtraction to separate, so it's like one term. So it's monomial. Next one, if I have something like that, again, to simplify it, I have to do the same thing as I did before. I can remove the bracket. So 9, p to the power of 10, q to the power of 7, 4, p to the power of 2, q to the power of 3, over 12, p to the power of 5, q to the power of 4. Now I can simplify. If I have a chance to simplify this constant, it's going to be great. So I can simplify the 4 with a 12. 4 divided by 4 equals 1. 12 divided by 4 equals 3. And again, I can simplify this 3. 3 divided by 3 equals 1. But 9 divided by 3 equals 3. So I simplify all of that to 3 as a numerator. Now, let's talk about the p. The p, I have 10 and I have 2. And this is multiplication. That means 10 plus 2. Then after that, I have a division. That means minus 5. Next, I have q. Q I have 7 and 3 as multiplication. That means I add the exponent. And after that, I have a division. That means I subtract the exponent. And now I can simplify more and more by saying 3p to the power of 10 minus 5 equals 5, 5 plus 2 equals 7. After that, the q, it's 7 minus 4. 7 minus 4 equals 3. 3 plus 3 equals 6. Or I can say 7 plus 3, 10. 10 minus 4 equals 6. Is this monomial? Yes, it's a monomial. Why? Because it's one term. It's not separated by addition or subtraction. That means it's one term. Next. Again, I can remove the bracket. So 10 p to the power of 5 q to the power of 2 times negative 4 p to the power of 9 q to the power of 11 over. Here I have to be careful. The 4 is affecting everything into the bracket. So that means 2 to the power of 4, p to the power of 4, q to the power of 3 times 4, 12. And now I can start to simplify if I have a chance. Be careful, the 2 exponent 4 here means 2 times 2, 4, 2 times 2, 4, 4 times 4 equals 16. So I can replace it with 16. Now, why I replace it by 16? Because I have a term negative 4 here. So I can simplify the 16 with negative 4. If I divide by 4, it's going to give me negative 1. If I divide by 4, it will give me 4. And I can simplify the 4 with a 10. 4 divided by 2 equals 2. 10 divided by 2 equals 5. So the 5 and negative 1, I can replace it by negative 5. And the 2, it will stay as a denominator. So now you can say that I finalize with the constant. Now I'm going to work with the variables. So now I can work with the p. I have 5 and I have 9. They are multiplied together. That means 5 plus 9. And I have another p as exponent 4, but this is as a division. That means minus 4. After that, the q. The q here, I have 2 and I have 11. And this is multiplication. That means 2 plus 11. But I have q as a division, which is 12. So that means minus 12. Now I can start to simplify more and more. So negative 5 over 2, the p here, it's 9 minus 4 equals 5, 5 plus 5 equals 10. And the q here, it's 2 plus 11 means 13, 13 minus 12 equals 1. So I can leave it as it is. And this is going to be my answer. And my question now, is this monomial? Yes, it's monomial. Why? Because again, there is no operation between the variables. There is nothing to separate them. So this is like one term. That means it's monomial. I hope you understood this lesson, and thank you for your attention.